Okay. We're going to kind of skip over a couple things as we do this. This is part C of these notes because yesterday we did A and B together. We'll just do this first example where we're going to find the inverse of these and graph. So there's kind of like a point we're going to get to of these. Okay. So if we're going to find the inverse of this function, we did this last night. This one's not a difficult one. Yeah, thank you. Divided by our 3. So our f inverse of x is, and for the purposes that I want to do for this particular, I'm going to go ahead and divide both of these by 3, so that's a 1x. So I'm going to do 1/3 x minus 3, instead of leaving it x minus 9 over 3, which is, you can do it that way also, but I'm going to do it this way because there's something I want you to notice whenever we get done with these. So if you, I've already got this graph here, you don't have to copy it, but if we graph this, the blue graph here is f of x equals x, 3x plus 9, then the inverse is the red graph right here. So you can see that they cross at a central point right here, that on the line y equals x, and then you've got one's increasing, one's or both are increasing, but they're at different steepnesses here. So let's do another one. Okay. So if we do f of x equals 2/3 x minus 6, to find our inverse here, we'd have to have x equals 2/3 y minus 6. And so we'll add 6 to both sides, so we get x plus 6 equals 2/3 y. And then right here, you need to divide by 2/3, but when you're dividing by 2/3, dividing fractions is as easy as pi. You're going to flip the second and multiply. So what I usually do for these instead is I multiply by 3/2 on both sides. Because if you multiply by that reciprocal, it's the same as dividing. And so you'll have like the 3's here cancel and the 2's here cancel. So you're just left with the y over here. And then I'm going to distribute that 3/2. So I'll have 3/2 x plus, let's see, that's going to be 18 over 2, which is 9 for that. And so that is our inverse function that we've got here. Let's look at the graph for that one. This time we've got our blue is our original, our red is our inverse here. You can still see symmetric about the line y equals x here, because that's the property we have for x, that is a property that we have for our inverses. And you'll look, they're both increasing, but one is steeper than the other. Let's do one more of these. So we've got f of x equals 8 minus 2x. So we will switch our x and y. So we'll have x equals 8 minus 2y. So we'll subtract that 8. X minus 8 equals negative 2y. Divide by negative 2. And so we get, again, I'm going to write it like this, negative 1/2 x plus 4 equals, I'm going to put f inverse of x here. And so if we look at the graph of those, again, the blue line is the 8 minus 2x. The red line is the negative 1/2 x plus 4. Symmetric over the x-axis. This time both of them are decreasing, but one is steeper than the other here. So I gave you all of these because there's something I want you to notice. I gave all of these are all linear. So what I want you to notice is I want us to look at the slopes of these. So the slope of this line is 3. The slope of its inverse is 1/3. All right, here our slope is 2/3. Slope of the inverse is 3/2. And for the last one, slope is -2. Inverse slope is -1/2. Right? So the conclusion that you can make from all of that stuff is that the slopes of inverse linear functions are reciprocals. So whenever you have inverse functions, their slopes are reciprocals of each other. Now this is for linear functions here. Obviously when you have some different, like you have a quadratic, it's going to have different slopes at different points. But we're going to see this, we're going to take this a little bit further here in a second. Questions so far? Okay, so here's the next thing that we're going to look at. We're going to let f of x equals x to the third, and that means the inverse of that would be the cube root of x, right? Those two operations are inverses of each other. Raising something to the third is the inverse of taking the cube root, and vice versa here. So what I want us to do here is I want us to start off just making a table for these. So for x and f of x, if I just take 0, 1, 2, 3, 4, we're going to make us a table for this here. And we talked about this a little bit yesterday. So if I'm plugging x into f of x, 0 to the third is 0. 1 to the third is 1. 2 to the third, 8. 3 to the third is 27. 4 to the third is 64. And so if we made us a table for the inverse function, and if we were trying to stick to whole numbers, the cube root of 0 is 0. The cube root of 1 is 1. We cannot find the cube root of 2 or 3 or 4 or anything all the way up to 8 is the next thing we can find the cube root of. So the cube root of 8 is 2. And then you should kind of be thinking about what we're having. The next cube root would be 27. The cube root of 27 is 3. And 64 would be your next cube root. The cube root of 64 is 4. So you can see how the function and its inverse are basically just tables that you've taken and switched the x and the y for these. So, like if we look at our table here, if I find, and we did this a little bit yesterday, if I find f of 2, if I plug in 2, I get 8. And if I find f inverse of 8, I get 2. And if I find f of 3, I get 27. And then if I find f inverse of 27, I get 3. So the function and the inverse undo each other. When you plug in a, you get b. When you plug b into the inverse, it takes you back to a. And so I drew one of these yesterday. Well, I drew one of these yesterday. This is called a mapping diagram. It's really not very, it doesn't seem very mathematical to me, but they do help me picture things. So, like, if you have the number 2, f is a function and it takes you over here and it gives you 8. So whatever the rule is for f, in this case, just cubing the number, f takes you to 8. So the inverse has to be the number that takes you back. So f takes you here, f inverse is the number that takes you back. So like for 3 and 27, f of 3, you plug 3 into f, it gives you 27. If you take 27 and plug it into f inverse, it's going to give you 3 for those. So, we are going to find, so we looked at linear functions at the beginning and we saw that they were, our slopes were reciprocals of each other. So we can't look at the slope of x to the third for the whole entire function. But we can look at the slope of the tangent line at that point. So if we have so we're going to take our two equations we have here, f and f inverse, and we're going to find the tangent line to f of x at x equals 2. And so to find a tangent line to f of x at x equals 2, we don't have to know anything about inverses here. This is just a tangent line. So for a tangent line, we need a point and a slope. Liliana, how do we find a point for a tangent line? Mm-hmm. 2 is your x coordinate. How do you find the y coordinate that goes with it? Okay, you're going to plug it in. So you just plug it into the original equation. So f of 2 equals 2 to the third, which is 8, which we've already done, right? But so you get the point of tangency that you have here is going to be 2, 8 there. So because for your point, you got to have x and a y coordinate. So the x will be given to you. The y you're going to find just by plugging in. Then we need a slope. And for a slope, what do we have to have, Destiny? Derivative. So this is a super simple derivative. F prime of x is going to equal 3x squared. And then we want the slope at 2. So we're going to find f prime of 2, which will give us 3 times 2 squared. So 3 times 4, which is 12. So if we want to write the equation of the graph here, we would have y minus 8 equals 12. Crazy. 12 times x minus 2. And just for the purposes that we're doing here, I'm going to go ahead and solve that for y. I just think it makes it a little easier to compare them in the end. Pre-response questions, stop here. You don't have to do that. So y minus 8 equals 12x minus 24. Add that 8. So y equals 12x minus 16. So that gives us our tangent line. So what I want us to do is I want us to look at the tangent line to the inverse at 8. And the reason I'm choosing 8 is because for our original function, 2 was my x, 8 was my y. So that same point on the inverse, x is going to be the 8, and 2 is going to be the y for that. So they switch which one is the x and the y. So we're talking about that same point, but on the inverse, it has been switched. So they're like corresponding points that you have here. So at x equals 8, we want to find the tangent line to f inverse of x. So first we have to find the point for f inverse of x. So this time we are plugging into the inverse, but f inverse of 8 is going to equal the cube root of 8, which is 2, which we've already seen quite a bit. So our point on our inverse is 8, 2. And then our derivative, so here's some notation that is a little bit annoying, I think. F inverse you gotta do F inverse. I'm going to put it in parentheses and put a prime out behind it. The negative ones and the primes really start to look the same, but is F inverse prime of 8? Well, let's do x right now. So when we take the derivative of this, it's easier to think of it as x to the 1/3. So we'll have 1/3 x to the negative 2/3. And I think it is easier to plug this in if you send this back to the bottom. 3x to the 2/3. And it might even be easier if we write this as 3 times the cube root of x squared. And so, if we want to find f inverse prime of 8, we would have 1/3 times the cube root of 8 squared. You could say 8 squared is 64 and then find the cube root of that. It's not too bad to do, but when you're doing the cube root of 8 squared, that is the cube root of 8 times 8, which is like the cube root of 8 times the cube root of 8. What is the cube root of 8? 2. So 2 times 2 is 4. So we've got 1/3 times 4, which gives us 1/12. And so your equation for this would be y minus 2 equals 1/12 times x minus 8. Oh, let's go in fractions. All I really care about the slope. I don't guess we really have to solve them. I didn't really have to solve this here. I could have just asked you about the slope. So, what I really care about the slope is here. The slope we found here was 12. The slope we found here was 1/12. So, you'll see, even if the functions are not linear, if they are linear, then your derivative is always the same, because the slope is always the same. So, if you have linear functions, then your slopes are inverses. But even if the functions are not linear, the inverses at corresponding points are going to be reciprocals of each other. So the slopes of all inverses are reciprocals. I guess I should sort of add like a, let me add something here. The slopes of all inverses are reciprocals for corresponding points. Okay, so I want us to look at one kind of graphically here, which I've got to add in. Let me know. Please don't freeze. Okay, so let's just take so I'm going to ask you to find F inverse prime of, let's see, one for f of x equals the square root of x plus 3. No, hold on. Not 1. I need to fix that. F inverse prime of 2. Because we are going to just like come up with this rule on our own, just like whoever it was that came up with it the very first time. So we're going to let g of x equal f inverse of x. So rather than calling g f inverse of x, I'm just going to call it g, just because it's a little easier to deal with. It's g. So if f and g are inverses, so we know f and g are inverses, then is this true? F of g of x equals x. If they are inverses, is that true? It must be. That was the first couple problems you had on your homework, where you had to verify those were inverses, so you had to find f of g of x, and it had to equal x, and you had to have g of f of x, and it had to equal x. So if these are inverses, this is a conclusion that we can make. So we could say, therefore, f of g of x has to equal x. Okay, so now I'm going to do some crazy stuff. I'm going to take the derivative of both sides of this. So I'm going to take the derivative of both sides. So to take the derivative of f of g of x, I've got to use a chain rule for that. So I take the derivative of the outside function, which is my f. So I've got f prime of g of x stays the same, times the derivative of the inside, which is g prime of x. It's basically just your chain rule written out here. And then I'm going to take the derivative of the other side, which is 1. And so now what I'm going to do is I want to know, what I'm looking for here is a rule for the derivative of the inverse. G is the inverse, right? So this right here is the derivative of the inverse. So if I want to solve this for the derivative of the inverse, I just have to divide by f prime of g of x. So g prime of x equals 1 over f prime of g of x. This is your rule for the derivative of an inverse. I'm going to switch back to inverse notation now. So we would call, instead of using g, I'm going to use inverse notation. So f inverse prime of x equals 1 over f prime of f inverse of x. Okay, this is the rule that you can use to find the derivative of the inverse. So we have 1 over f prime of f inverse of x. That's the rule. So let's try to look at least one problem here, maybe two. So we've got f of x equals 1/4 x to the third plus x minus 1. What we're eventually going to find here is f inverse prime of 3. That's eventually what we're looking for. But before we can do that, or not of 3, I guess. It's going to be of a different number. But it's going to be okay, no. Yes, it is going to be f inverse of 3. So what is the value of f inverse of x when x equals 3? So if x equals 3 for the inverse, then it equals the y. So if it equals 3 for the inverse, then it equals the y for the original function. So if it's x for the inverse here, it's y in the original function. So if we are looking for the x that gives you 3 whenever you plug this in. So what we'll do here is we will find we'll put a 3 here, and so we'll have 1/4 x to the third plus x minus 1. And then I am going to multiply everything by 4 to get rid of that fraction so that it doesn't, so I don't have to do anything with it. So I'm going to multiply everything by 4. So I'll have 12 equals x to the third plus 4x minus 4. and then solve this, I will move the 12 over. So 0 equals x to the third plus 4x minus 16. Now, the only way we know how to solve that is to do synthetic division. So we would have 1, 0, 4, negative 16. I can tell you that 1 does not work because 1 plus 4 plus negative 16 is not 0. And we could try several different ones, but I already know the answer, and I know that 2 will work, so I'm going to tell you that for our sake of time here. But you would have to try different values. So so we bring down our 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 4 plus 4 is 8. 8 times 2 is 16. And that gives you a 0. So, so 2 is the value that you would use here. You actually could go ahead. This is going to be x squared plus 2x plus 8. You actually might have more than one answer here, but I'm just going to tell you for the sake of time that if you do this, that you're going to not get an answer out of that. You're going to get like a irrational answer. You have to do quadratic formula. There'll be an I in the answer. So not irrational, but imaginary. So so that does not give you anything. So x equals 2 is the value that you're looking for right here. So f of 2 equals 3. F inverse of 3 equals 2. Okay, that we need for the next part that we're going to do. Okay, so for the next part it says, what is the derivative of f inverse of x at x equals 3? And so here is where I use that rule that we just wrote down. So f inverse prime of x equals 1 over f prime of f inverse of x. Prime's on the outside, inverse is on the inside. And we are asked to find this at 3. So I guess I could go ahead and plug in 3 right here. So this is this f inverse of 3. This is the part that we just did. What did we find for the f inverse of 3? Up here we had 2, right? So so that means that we are going to find 1 over f prime of 2. And I don't know f prime of 2, but I know f of x is 1/4 x to the third plus x minus 1, and that's pretty easy to find the derivative of, right? So so I'm going to say f prime of x equals, and then you'll have 3/4 x squared plus 1, and then you'll just have minus 0 for that last part. So that'll be your derivative. So f prime of 2 would be 3/4 times 2 squared plus 1. And so that is 3/4 times 4, which is like 4 over 1, plus 1. And 4's cancel, so you just get 3 plus 1, which is 4. So f prime of 2 is 4, so 1/4 is our answer for that problem. And we really need to do the last problem, but we don't really have time. So we're gotta tell them their homework assignment, because I have lost where I wrote it down. Make sure this is right. 186. Page. Sorry. It's going to be page 186, 1 through 10. Yeah. So that'll be your homework assignment. I'll check it on Tuesday. I'll finish this problem. I might even do one of the homework problems so you can see that as well if you need to look at it. And then on Tuesday we'll check it and go over it, and we got some more stuff to do with the inverse stuff. So for this one, if we're finding f inverse prime of negative 2, if we use that formula, then we've got to do f, let's see, f inverse prime of 2 equals 1 over f prime of f inverse of 2. So the first thing you've got to find is f inverse of 2. So here, 2 is the x for the inverse. So that means it's the y for the original function. So we would plug in 2 for our y here. So we have 2 equals, let's switch back to blue, 2 equals 2x to the 5th plus x to the 3rd plus 1. We would subtract that 2 from both sides. So we'll get 0 equals 2x to the 5th plus x to the 3rd minus 1. And so if we're going to do synthetic division for this, then we would have 2, 0, 1, 0, 0, negative 1 here. And you can see 2, 1, and negative 1. 1 is not going to work for this. I'm going to help you cheat a little bit and tell you that negative 1 is the value that works. So if we check this, 2 times negative 1 is negative 2. It's negative 2. Negative 2 times negative 1 is positive 2. It's 3. 3 times negative 1 is negative 3. Negative 3. Negative 3 times negative 1 is positive 3. Hold on, I've messed up. Here was my mistake right here. This was supposed to be a negative 2, so that was a negative 2, which is positive, which makes you have a positive 3 right here. So that number right here should be a 3, which will be much better, because 3 times negative 1 is negative 3. You get 0 here. So negative 1 works. So what we find here is that f inverse of negative 2 equals negative 1. So that's the x for the original function. That gives you the y of negative 2, or an x here gives you y of negative 1. So we found this part that we have here in red. So actually I'm going to move this down a little bit so I can just keep working across. So what we've got now is we've got to find f prime of negative 1. And so f prime of negative 1, we've got our function. It's fairly easy to find the derivative of. So f prime of x is going to be 10x to the 4th plus 3x squared. And then that plus 1 is just going to be a 0 there. So if we find f prime of negative 1, we'll get 10 times negative 1 to the 4th plus 3 times negative 1 squared, which is going to give us 10 plus 3, which will give us 13. So f prime of negative 1 is 13, so our answer is 1 over 13. And you can see the derivative at negative 1 is 13. The derivative at the corresponding point, which is, sorry, that should be a negative 2. Negative 2 is 1 over 13. They're reciprocals of each other. The homework is going to be page 186, 1 through 10. I'm going to do one extra question from the homework in case you have some questions there. So let's do number 6, because it's probably going to be your hardest one. So f of x equals cosine of 2x, and we're only looking in the first quadrant. And we're looking at a equals 1, and we are supposed to find f inverse prime of x, which means, and so our a is of 1. So that means we got to do 1 over f prime of f inverse of 1. So we're going to start with this f inverse of 1. So we've got 1 is the x for our inverse, which means it's a y for our original. So we'll do 1 equals cosine of 2x. So we have to ask ourselves, where does cosine equal 1? And so on that unit circle, right here at 0, our cosine equals 1. So what you're doing here is like you're doing cosine inverse of both sides. And so when you find cosine inverse of 1, you're asking yourself, where does cosine equal 1? That is at 0. So you get 0 equals 2x, and then just divide by 2. And so x equals 0. So the f inverse of 1 is going to be 0. So we're going to have 1 over f prime of 0. So now we have to find f prime. F prime of x is going to be, you have to use a chain rule for this. So your outside function is cosine. So the derivative of cosine is negative sine of 2x. And then you're going to multiply that by the derivative of the inside, which is a 2. And so the the derivative of f of x is negative 2 sine of 2x. And we are interested in f prime of 0. So that would be negative 2 sine of 2 times 0. And that will give us negative 2 sine of 0. Sine of 0 is 0. So we just get negative 2 times 0, which is 0. So for this one, we're going to get 1 over 0, which 1 over 0 is undefined. So for our answer for this one, we get undefined.